Okay, so in this video, we're going to talk a little bit about two-dimensional arrays. We'll go through some implementation of a couple of different things that we can do with two-dimensional arrays. And then as we get to the end of this video, we'll wrap up by also discussing a little bit about three-dimensional arrays and arrays of larger dimensions as well. So to start off with, we're going to go through a conceptual discussion of two-dimensional arrays. To get a general idea about precisely what a 2D array is, when we think about how this is going to be structured in our program, we'll first consider the arrays that we've been working with so far. So far we've been dealing with these what are known as one-dimensional arrays, where essentially the items of the array, or the individual elements, are being placed into it along a single dimension, so just a straight line. We add some numbers to this if this is an integer array. And now what we want to do is, instead of only doing it along this straight line, so say we consider this maybe a single row, we want to instead introduce a combination of multiple rows, and for each one of these multiple rows we effectively have individual columns. So go ahead and separate this out accordingly. And so in this particular example, what we can imagine is that we have 3 rows, and in each one of these 3 rows, we're going to have 4 different columns. Okay. So looking at this, this sort of abstract construction of it, what I want to then go ahead and do is actually implement in code a two-dimensional array with these same dimensions. So I want it to have 3 rows and 4 columns. Okay. So we're going to come over here. I'm going to create a new program or a new project. I'm going to call this 2D arrays.java. Then go ahead and have our public class 2D arrays. We'll then have our main method, so public static void main. Our string array of arguments. And then inside of here, I'm going to go ahead and declare and initialize this two-dimensional array. To start off with, we'll do an initialization by using the new keyword and the array constructor. So we're going to have our integer, specifying the data type for the individual items of this two-dimensional array. They're going to be ints. We then have not simply one of these pair of brackets, but actually 2 of them to indicate that this is going to be 2 dimensions. And then for the name of this, I'm just going to use the same naming convention that I've been using for my arrays, and just call this numbers. So this is going to be equal to a new 2-dimensional int array. So we're going to again have that 2 pairs of these brackets. And then for each one of these pairs, I need to provide a size declarator, one to specify the number of rows, and then another to specify the number of columns. So the first item, this first box right here, we're going to put in the number 3. So that's going to specify that we have 3 rows. And then the second one, we're going to specify 4. So this specifies the 4 columns that we're going to be using. And then of course, if we need to access these later, whenever we are trying to get or maybe assign a value to a particular location inside of this two-dimensional array, keep in mind this pair, the first box is going to be for row, and the second one is going to be for the column. Okay. So now that we're seeing that structure, I want to then go ahead and actually set up a for loop to be able to add items to this array. But since we're now working with a two-dimensional array, it's important to keep in mind that I can't use just a single for loop by itself to step through this array, because now what I need to do is actually include 2 nested for loops, one to be able to step through the rows. So we're going to step through each one of these 3 rows, and then a second one to step through each one of the columns. So essentially, whenever we get into a particular row, we're going to step through each one of the 4 items, or the 4 positions of that row. Okay, so when we do this, we're going to have an outer for loop that we use for the rows. So we're going to say for int row equal to 0 initially. So just like our index for our one-dimensional arrays, when we deal with this row and column, these again are still going to be 0 based. We're still working with arrays. So we're going to make sure that the row starts from 0 and also that the column starts from 0. So we're going to say row equals 0. We'll keep going for as long as the row is less than the size or the number of rows that we specified. So as long as this is less than 3, and then we'll do row plus plus. since we're going to increment through the rows as we go. The next part we're going to include is going to be the inner for loop. And for this one, this is going to be for when we go through each one of the individual items, or essentially for each column of this two-dimensional array. So we're going to say for int call, again, it'll start at 0. This will keep going for as long as it is less than the number of columns. And again, we're going to increment this. Okay. And then inside of the body of this inner for loop, I want to go ahead and introduce another variable. So I'm going to go ahead and create another variable up here. I'm going to be incrementing that variable as I go through this, and then I'm going to take that value and assign that to a particular location inside of this two-dimensional array. So I'm going to make an int variable called number. I'm going to initialize it to 0, and then right here I'm just going to go ahead and increment it. So keep in mind that this is going to be inside of the inner for loop, so this is going to be incremented for every one of the times that we iterate over this inner for loop, including for every instance that we iterate through the outer for loop. So we're going to go through the outer for loop 3 times, and we're going to go through the inner for loop 4 times. So when we combine these together, we're going to end up going through this, this inner for loop a total of 12 times. So when we increment this, we're going to increment it from through the numbers 1 through 12. So I'm going to go ahead and assign those numbers 1 through 12 to each one of the locations inside of my my numbers array. Okay, so we will go ahead and put this in right here. So we're going to take our numbers array. We're going to specify that we want the row and that we want the column. And we're going to say this is equal to whatever value number currently holds. All right. And then the next thing I want to do, now that we've assigned some values to each location of this two-dimensional array, I then want to go ahead and print that out. But before I print this out, we'll also go ahead and look conceptually at how I've gone about adding numbers to this. So let's take a look at a couple of these. So the very first time that I increment this, we're going to place the number 1 at this position here. The next one, I increment again, and we're going to place the number 2 right here. And then increment again, I'm going to place the number 3 right here. And then I'll increment once more and place the number 4 right here. After I've gone through this 4 times, that's going to be the first time that I go through this inner for loop. So I'll go through that 4 times. We then come back to the beginning of the outer for loop and move into the next iteration of that, which takes us into the second row. So right here, we'll increment again, and we'll go through this and get the numbers 5, 6, 7, and 8. And then after we go through all that, we again reach the end of this inner for loop. We come back to the beginning of the outer for loop for the last time that we go through that for the third row right here. And for this one, we will again be incrementing number, and we'll get the values 9, 10, 11, and 12. Okay. Alright, so the next thing I want to go ahead and do, since we're going to go ahead and set up that print statement, I want to try to set it up so that it prints out the values in basically the same sequence as we have right here, where we're going to print out the numbers 1 through 4 on their own line. We'll then print out the numbers 5 through 8 on the next line, and then the numbers 9 through 12 on the third line. So we're going to go ahead and take this nested for loop, or this nested set of for loops that we have right here, since we're going to be using the rows and columns again. I then need to go ahead and replace this part right here. So what I want to go ahead and do is do a print statement, and we're going to print out the number that we're interested in. So we're going to have numbers at row and column, and then I'm also going to add a space so that we can separate out the numbers. So the first time I go through this, it'll print out the numbers 1, 2, 3, 4 with a space separating them. The next time it's going to be the numbers 5, 6, 7, and 8 with spaces separating those. And then the last time is going to be the numbers 9, 10, 11, and 12, again with a space separating those. And then the other thing I'm going to do to make sure that each one of these is going to be on a new line, after I go through this inner for loop to get the individual items for this, the very next thing I'm going to do at the very end here, so after I'm done with this inner for loop, but before I'm completely finished with this outer for loop, I'm just going to go ahead and include a print line statement to effectively introduce a new line character at the end of this. Okay, so we'll go ahead and compile this. So we're going to do javac 2D arrays.java. We'll then go ahead and run it. And we can see right here we get our numbers 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, 11, 12. And of course, because of the fact that 10, 11, and 12 are, have 2 digits, the spacing for it starts to go a little off. But otherwise, we can see the general structure here that matches up with this structure for a 2-dimensional array. Okay. So in addition to being able to initially construct the array by just specifying the number of rows and columns, we could also just go ahead and insert the individual values at the moment when we are declaring this 2-dimensional array. So I'm going to go ahead and comment out everything that we have right here. And then coming up here, let's go ahead and comment this out as well so that I can instead just go ahead and remake numbers with this new approach or this new initialization. So again, we're going to use numbers. And this time what I'm going to do is I'm going to create my pair of curly braces. And I'm going to go ahead and add a space here. And inside of this pair of curly braces, to introduce each one of these individual rows right here, I'm going to use yet another pair of curly braces. Okay. And inside of this, this new pair of curly braces, for this first one right here, this is going to be for the numbers 1 through 4. So we're going to have 1, 2, 3, and 4. We can then step out of this inner pair of curly braces. We'll put a comma right here. We'll go ahead and move to the next line. I'll go ahead and tab this over a couple of times to make sure that everything is lined up. We're then going to include the items for the next set. Let's see. Okay, so we're going to get that placed right there. And then in this next one, we're going to have the 5, 6, 7, and 8. We'll have a comma on the end of that. And then for the last one, again, we're going to have that pair of curly braces. And then we're going to do 9, 10, 11, and 12. All right. So this inner pair of curly braces for each one of these is going to correspond to a particular row. And then this outer pair of curly braces basically encompasses the entire 2-dimensional array. And at this point, you might be able to already kind of tell what it is that's going on whenever we make a 2-dimensional array because of the fact that we have to use these kind of nested set of curly braces. In actuality, the way that we're building this array is that essentially 2-dimensional arrays are just basically what we would consider to be arrays of arrays. So effectively, this outer pair of curly braces is just saying that I want to create an array that consists of 3 integer arrays. And so then we have each one of these 3 integer arrays, which consists of 4 integers. All right. So because of the fact that this is a 2-dimensional array, using an array of arrays like this, that also means that we can actually use the various properties that come with arrays. In particular, that means that we have access to the length field. So there's actually another way that I could write this statement that I have right here. Instead of having to hard code the values 3 and 4, say maybe I want to create something that's a bit more general so that I could use it for a 2-dimensional array with any particular sizes for the number of rows and columns. So what I can go ahead and do here is just say 4. Again, we're going to use our row, so we're going to say int row is equal to 0. We're going to do this for as long as this row is less than this numbers dot length. So numbers itself represents the 2-dimensional array, so it basically represents this outermost array, meaning that the size of this is going to be this 3 right here, because it consists of 3 distinct or 3 unique integer arrays. So the length here is 3. We'll then go ahead and increment that. And then inside of here, we're going to have our inner for loop. So we'll have our column go to 0. And for this one, what I can go ahead and use is a pretty much any one of these 3 these three inner arrays, I can just go ahead and get the length of any one of those three inner arrays, and that can be used for the number of columns that I'm going to have. So obviously, since we can never really guarantee precisely what the size of our two-dimensional array is going to be, the easiest way to guarantee that we are getting an array that actually exists is to just go ahead and get the 0th array, because at the very least that one must be in there. So we'll say numbers 0 dot length. So this number 0, when we get the length of that, that's going to be this 4 right here. We'll then say column plus plus, and then right here we're just going to go ahead and do this print statement. So I'm just going to come up to this commented out line, go ahead and grab that, place that right there, and then right here we'll go ahead and insert that print line statement as well, and then we'll go ahead and run this and just print out the contents of this array in exactly the same fashion as we did before. So we'll go ahead and compile this, and then run it, and we'll still go ahead and get those numbers 1 through 12 printing out. Okay, so now that we've seen a little bit about being able to declare and initialize our arrays, discussing a little bit about both using the constructor as well as just initializing the individual items. We've also looked at the usage of the length field, as well as being able to use the length field of the individual or the inner arrays within that two-dimensional array. The next thing I want to go ahead and look at is a couple of different kinds of very simple algorithms that we might be able to apply to a two-dimensional array. So in this particular case, the main things that I want to look at are a couple of different ways that we might go about accessing the items inside of this array. The easiest way to demonstrate this is different ways that we can go about calculating some totals for different components of this array. So the easiest one that we can start off with is just getting a total of all of the items in the array. So we'll go ahead and create a variable right here. We'll call this int total. We'll initialize that to 0. We again are going to go ahead and create our 2 for loops. So this time around I'll go ahead and reconstruct them. So we're going to have our int row starts from 0. We're going to keep going for as long as this row is less than our numbers.length. We'll increment that. We'll then have our column do the same thing for int call equal to 0, as long as call is less than numbers 0 dot length, call plus plus. And then inside of here what we're going to do is just add to the total using the combined assignment operator. We're going to add to it the value that we get at that particular position in the array. So in this case we're just going to add numbers, row, and column. Okay. And then after we do all of this, we'll go ahead and just include a single print statement at the end here. For this one, we'll say the total is plus whatever total happens to be. So we'll go ahead and save that and run that and see what the total is when we add the numbers 1 through 12 together. So we'll compile this, run it, and we have the total right here at the end, which is 78. All right. The next two kinds of totals that I want to do, I'm first going to do one where I show how to get the total of the rows, and then I want to also show how to get the total for each of the columns. Okay, so for this one, again, we're going to have our integer variables. The first one is going to be, let's say, row total. This will also be initialized to 0, and we'll also go ahead and include a column total. This will also be equal to 0 initially. For each one of these, let's start with the row total. This one's going to match up with our total, at least for the most part. So I'm going to go ahead and copy and paste that down there. And the one thing I need to go ahead and change is that whenever I get the row total, this is going to need to be reset whenever I start a new row. The reason for that is that when I add these numbers together, so I'll add like 1, 2, 3, and 4, this will give us the number 10 for that row's total. But then when I move to the next one, I need to go ahead and start that row total over again, because I don't want to add the 10 that I got from the previous one to this. Otherwise that kind of defeats the purpose of that variable. So we're going to go ahead and include a line right here to make sure that the row total is essentially reinitialized to 0. And then right here, we're going to go ahead and get that row total and add to that each one of the numbers that we get from that particular row and column, so that particular position in the array. And then just like what we did up here, where I had this print line statement for when I was printing these out, when I was finished with the items in that row, I want to also go ahead and include a print statement here to just go ahead and print out the total after I've gotten it for that particular row. So I have a print line here. For this one, we'll say row plus row, we'll say has a total of plus our row total. Okay, so this is going to give us the particular row that we're on. So this is going to go through 0, 1, and 2. So for row 0, it will tell us that it has a total of 10. For row 2, or row 1, it will tell us that it has a total of whatever 5 plus 6 plus 7 plus 8 will give us. And then for row 2, that has a total of whatever 9 plus 10 plus 11 plus 12 gives us. Okay, so we'll go ahead and compile this and run it. And so now we can see row 0 has a total of 10, so that's correct. Row 1 has a total of 26, and then row 2 has a total of 42. And then if we were to add all three of these rows together, that gets us back to this overall total. So if we do 10 plus 26, that gives us 36, and then 36 plus 42 gets us back to our 78 that we had. So let's go ahead and clear this, free up some space there. Come down here. So go ahead and add a few extra lines so we can more clearly see this. For this next one, we're going to be looking at this column total. So for the column total, the way that I want to do this is I essentially want to just go through each one of these columns and add these three numbers together. And the easiest way to do this is basically it's just going to be the inverse of the way that we were approaching the row total. And to get the inverse, all we have to do is basically just flip these two values that we're using in our for loops. So now what we're going to say is for int column equal to 0, while column is less than our numbers 0.length column plus plus. And then for the inner for loop, we're going to do the rows. So we'll say for int row equal to 0, row less than numbers.length, row plus plus. And then right here, we're going to go ahead and do the column total now. Again, also making sure that we reset it right here. So make sure that our column total is being reset to 0 when we move from one column to the next. And right here, we're just going to add to that the values at each of the three positions that we're interested in. So like for the first one, we're going to add row 0 column 1, or row 0 column 0, row 1 column 0, and then row 2 column 0. So we'll do 1 plus 5 plus 9. For this first one, this will give us 15. For the next one, we're going to get 18, and then so forth and so on. So print those out. So we'll say column plus our call as a total of plus whatever the call total happens to be. Okay, so we'll go ahead and compile this and run it, take a look at it. Okay, so then we can look down here. We see we've got column 0. We have a total of 15, as we noted before. Column 1 has a total of 18. Column 2 has a total of 21. And column 3 has a total of 24. Okay, so each one of these matches up with exactly what we're expecting. And again, if we were to add all 4 of these columns together, that gets us back to our overall total of 78. Okay, so the next thing I want to go ahead and talk very briefly about is a particularly unique aspect of two-dimensional arrays that I've not really been addressing, which is that right now I've basically been working under the assumption, especially when I was doing all of these totals, and I was using something like numbers0.length. There's a particularly curious question that you might have about what would happen if the sizes of these inner arrays, if those didn't actually match up with each other. So maybe whenever we declare it, we don't necessarily specify the size right here. So to give you an example of this, let's say we go ahead and create a new integer array. I'm going to call this ragged, since this is going to be what are known as ragged arrays. And for this one, whenever I initialize it, we're going to say a new integer array. We'll say that we still want 3 rows, but for the number of columns, we don't specify anything here. So the sizes are kind of just up to us now. And so then, whenever I go to create an item, create an array that I want to assign to each one of these locations. So say I want to assign something to 0, to 1, to 2. For each one of these, I'm going to make a new one-dimensional array that I will then insert into my two-dimensional array. And for each one, I'm going to give it a different size. So maybe for the first one, I give it a size of 1. For the next one, I'm going to give this a size of 2. And then for the last one, I'm going to give this one a size of 3. Okay, so if we try to imagine what this looks like now, say if we come over here and try to construct this, basically what I've done is I've created an array where the first one has 1 item, the second one is going to have 2 items, and the third one is going to have 3 items. So I'll have something kind of like this. So at this point now, the number of items in each array is different, which also means that what I was relying on before when I said number 0.length to try to keep track of the number of columns, that's no longer going to work, because once I get into the next one, well, the length of number 0 is 1, this has more than 1 item in it, and this has more than 1 item in it, so there's going to be things that I'm missing. Conversely, if I did this the opposite way, where this 3, or this array of a size 3 right here, if I had used this one's length, well, then I would run into issues where I'm now going out of bounds for the arrays up here. So that also introduces its own set of problems. So instead, what I need to be able to do is try to check for the size at that particular location. So instead of being able to use number 0, let's say I want to go ahead and take, let's say, this construction right here, or maybe this one right here. So before we went ahead and assigned some values to it. So yeah, so right here, we'll go ahead and do this again. So we're going to do for our int, we're going to still call this row equal to 0, as long as row is less than numbers.length of row plus plus. And then for the inner loop, what we're going to do is say now for int column equal to 0, and while column is less than our numbers, and instead of specifying 0 here, we're instead going to specify the row. So now what we're going to do is check for the length of the array at this particular row in our two-dimensional array. And then we'll do call plus plus. And for this one, I'm going to go ahead and just add in the numbers 1 through 6. So again, I'm going to go ahead and introduce another variable here. We'll call it number. Set that equal to 0. Right here, we're going to increment it, and then go ahead and append that. So we'll have our numbers, or a ragged. I should go fix this as well. So we'll have ragged for our particular row and column. This is going to be equal to whatever that number happens to be. And once we've done that, then we can go ahead and actually print this out. So again, we're going to use this same structure right here. The difference being that now we're going to have that print statement. So we'll just say system.out.println. This should be a print statement. We will print out our value at a particular row and column in our ragged array, plus we'll have that space, and then we'll also include our print line right here. Okay, so by doing it this way, we can go ahead and add 1 item to this first array. So we're going to add the value 1 right here. So that's going to be covered the first time we go through this inner for loop. We're going to reach the end of that because of the fact that we're checking for the length of that first row. We then go into the next row. We'll add the values 2 and 3 right here. That'll reach the end of the second iteration through this inner for loop, or the second set of iterations through this inner for loop. We'll then come back to the outer for loop and then go through this a third time to get the numbers 4, 5, and 6. Okay. So we'll go ahead and compile this and run it. Okay, so we get all of our information from the previous two-dimensional array, and then right here at the very end, we can see that ragged array where we've got a 1 for the first row, which only has a size of 1. We have 2 and 3 for the second row, which has a size of 2. And then we have 4, 5, and 6 for the third row, which has a size of 3. Okay. And of course, one of the other things to keep in mind about this, if you're looking back over some of these other examples and thinking about how to do them with ragged arrays, it's important to keep in mind that this one right here, for when we calculate the columns, I'm not going to go into any detail about exactly how to fix it. I'll kind of leave it up to you to figure that out. But you can't really rely on this row anymore because row is not declared within the scope of this set of expressions for this outer for loop. So when you replace this 0 with something corresponding to the row that you're on, keep in mind that you can't directly just use row. Okay. So this is going to cover everything for two-dimensional arrays. In addition to this, I also want to briefly talk about three-dimensional arrays and everything that kind of goes beyond three-dimensional arrays. So we're going to come over here briefly. For this part, I'm just going to talk about this conceptually. I'm not going to worry too much about trying to do examples with this, mostly because at that point it becomes very lengthy and very complicated. Instead, we're just going to discuss this conceptually. But essentially, if you want to declare a three-dimensional array, it's basically just the same as what we saw for the two-dimensional array, except now we're just adding one additional pair of brackets to our declaration, and we also have one additional dimension whose size we need to specify. So when we do this, if you want to try to imagine what this would look like in a more abstract sense, what we can do is we still have our rows and columns for a single two-dimensional array, but now to add this third dimension, we're going to introduce a number of pages. So in this case, we've got pages 0, 1, and 2. That corresponds to this first value, so this first 3 that we've included right here. The second one is going to be the number of rows. So we're going to have rows 0, 1, and 2 for this one. And then finally, this last value right here corresponds to the 4 columns. So we've got 0, 1, 2, and 3. So as I mentioned before, when we talked about two-dimensional arrays, where it's basically a single two-dimensional array is the equivalent of an array of arrays, well, now a single three-dimensional array is essentially going to be an array of two-dimensional arrays. Okay. And then in addition to these three-dimensional arrays, we also can introduce arrays of more than 3 dimensions, but at that point it becomes a bit more difficult to try to describe them using an abstract visual metaphor, kind of like what we did for the rows and columns with two-dimensional arrays, and then the introduction of pages for three-dimensional arrays. Once you get into a 4-dimension, at that point then it's basically the equivalent of like a hyperspace. It kind of starts to make almost no sense visually. But there are some practical cases for whenever you're using arrays with more than 3 dimensions. So to leave you with something to consider, sort of a broader topic when it comes to arrays, I want you to consider certain scenarios where it would actually make sense to use arrays of several dimensions, say like 4 dimensions or more. All right. So at this point, this is going to wrap up everything for multidimensional arrays. In the last video for this set of videos related to arrays, we're going to talk a little bit about the ArrayList class.